Hi there, my name is Musa Yaneyu. I'm presenting my final project, Data 620 Web Analytics for Summer School 2017. It's going to be based on social network analysis, which is a process of investigation social structure through the use of network and graph theory. The description, I will obtain the summary statistics, plot, like a graphical representation of the data set, find the similarity and the differences of the data set, text of hypothesis, dive into recommended system, data cleaning, prediction, etc. So for this course, we are required to actually either do a project on network analysis and text processing or both. So I'll go for both. So my project will be based on network analysis and text processing. The data will be comprised of two types of data sets. One will be for the network and then the other will be for the text processing. Here is a link to the data set for the first one, and then here's a link for the data set for the second one. So we have to load our library, and then let's begin. The dataset will be read into this environment. I'll be using R. So here I'll obtain the head, and then I will obtain the dimension. The dimension is actually 1000 by 4. That is 1000 observation and 4 variables. So here is summary. They are all integers. So for there we're gonna uh, we're gonna transfer the data set to our graph data set. So we convert it to our graph data set. So for easy accessibility with the iGraph library. From here we see that the data set comprises of 670 nodes and 1000 edges. Before we move on, let's see how the data set looks like. Here I'll obtain data set and then I reduce the size to 500, and then this is what I get. The layout for this is gonna be a layout with KK. Yeah, should it look like a hat? And for layout with LGL, this is how it looks like. It's beautiful. So let's get the edge out, edge, and then here's the structure of the data set in the graph environment, and here's the edge, and then I obtain the means of all the edges. The mean is actually 500.5, and then the vertex which denote the same. I obtain the mean, that's 335.5. Also, I obtain the standard deviation, for the vertex, and the standard deviation for the mode. Mind you, the standard deviation is used to quantify the amount of variation or dispersion of a set of data value for both nodes and then the edge. So we want to know the dispersion or the variation from the mean. With this, if the standard deviation is bigger, that shows there is a wider variation. If it's small, that shows we are good to go. The smaller it is, the better it is. So we actually want to go to degree centrality. This is the number of link incidents upon a node. That is the number of ties a node has. So that is the formula to obtain that. And as well, here it is made simple here. Here is the summary of the node here. Of the centrality, degree centrality. Here is what we can get here. We see that the maximum is 354, and then the minimum is 0.00. Actually 354 and 0. Okay. And again, we move forward to obtain the closeness centrality. This is the length. This is the average length of the shortest path between the node and all the other nodes in the graph. So here's the mathematical representation. Sum of y, d of y and x. Um, Again, here's the summary of for the edging centrality here. I commented it out here because the value was so big, so it takes a lot of time. So if you actually want to say we could comment it out, but I actually obtained the value. Here's the main, and then a beautiful plot here for the cluster edge between us. It's beautiful. For analysis, so we want to dive into real analysis. Here we obtain the summary statistics. We have the minimum to the maximum, the minimum and the maximum for the from columns, and minimum and the maximum, and then the width for the minimum and maximum. Their respective standard deviation as well. Before we move on, we actually want to know the correlation between the from and the to variables. We can see that the correlation actually is actually low, and for the 95% no confidence interval, though they are really non-zero, and then the value for the correlation coefficient here is negative. So this is weak negative correlation. So by so doing, we are trying to go into regression to actually look in to actually see the difference. Here we set up our test of hypothesis. The new hypothesis is like the mean 1 and mean 2 to mean 3 up to mean n, that they are the same, and against the alternative hypothesis, which is either one of the means are not the same. So the distinction here is we have to reject the p-value. We will have to reject the h-naught rather if the p-value is less than tabulated value. Our tabulated value will be at alpha equal 0.05. So here is the formula for obtaining the regression, and then here is a summary statistics. For the regression, we obtain the p-value to be 0.00000022 here, which is very, very low compared to the alpha at 0.05. So from here, we can reject h-naught, accept p-value. But before we do that, we actually want to move forward, actually do further verification. So that is why we'll do a model selection to actually see the best model, because we're thinking there might be an interaction between all these other variables that are actually making the p-value to be lesser. And again, after that, we still say that the p-value is still less than the alpha, but we still don't accept that fully. So we actually want to obtain the analysis of variance to see whether there's a statistical significance between the group of means. Sum of square total, sum of square, sum of mean, sum of square, and then the f value, the degree of freedom is. So here is the confidence interval. So from there, the confidence interval shows us that they are non-zero. 8 to 1, there's none of them has a negative or any other opposite signs, so they are non-zero. That is, this gives us a kind of a green light, and we still don't agree. We still want to go further to actually test. So we we have that 2K post test. So we set up the 2K post hoc test, and then we actually still obtain the same value. So from here, we are going to conclude that the p-value is actually less than the tabulated value, and the correlation coefficient is weak negative. The confidence interval of the stepwise best model solution is still now zero, and the Tokyo HD post-arc output support the initial analysis of variance outcome. So we can therefore conclude that there was statistically different between their means, and then the new hypothesis is therefore rejected. So let's go to recommender system. Recommender system, we will convert the dataset to a matrix, and then we sample out for matrix, and then we convert it to evaluation scheme, where we use a bootstrap method. We are looking for a rating that is from 3, good rating of 3, and then we reduce the we split the dataset into 90 and then 90% and 10% for the test. 90% goes for the train. So we are converting to recommender system. We actually get a prediction here. So we want to type of a rating, kind of a prediction, and then we get a plot for the prediction here. And as well, we want to calculate the prediction accuracy. We want to know if the prediction is actually accurate. So we'll be using the method IBCF. From there, we obtain the root mean square error. We obtain the mean square error. We obtain the mean absolute error. So these are the root mean square, the mean square, and then the mean absolute error value for it. And also we want to obtain the convolution matrix. This convolution matrix is a table that is often used to describe the performance of a classification model on a test model for which the true values are known. So we want to use this convolution matrix table to actually give a presentation of the value we get for the true positive, for the false positive, the false negative, and the true negative, the precision, the recall, and then the CPR and the FPR. So that is the value we get from there. As a matter of fact, we still want to go in depth to actually check for the receiver operating characteristics curve. We call it a ROC curve. This curve is used to graph the summary of the performance of a classifier over a possible threshold. So here is the ROC curve. The ROC curve normally should be a curve that goes to here and then curve here. That will be about close to 90 or 100%. So we obtain the precision recall as well, which actually a bit more better than the ROC. Oh, that's part 1. Here is part 2. In this part, we will make use of our text files. So please load these following libraries. These are the list of the link, or rather to the text files we'll be using. So we can follow this link, and then we get the text files. If I should copy these and then obtain this, um, we can see it here. These are the text files. So we'll be doing an analysis on these text files. This is one of them. Actually, it's gonna be 5 of them. So one will be based on review, while the other tools are based on negative reviews and positive reviews. Here is when we read out the data and then we obtain the edge. So here is the edge for the positive and negative, and then the combination of the two. And again, we before we can work on this, we can see that we have a lot of characters there that are really not welcoming. So we don't want them. So we actually get all the pronunciation, the digits. We take them off. All these characters, we actually don't want them. So we get rid of them. So after getting rid of them, we now want to convert the text file into corpus. So here is the conversion of for the negative, for the positive, and for the review plain text. And then we take out the we first of all convert them to lower, and then remove any numbers, any punctuation, any word with and there. We strip out the white spaces. So after that, this is what we get for the first text file. For the negative text file, and this is what we get for the positive text file. And here is what we get for the review. And again, after that, we convert the corpus to the document text matrix, and then we remove any sparse term, and then we inspect them. So here are the terms we actually get from the inspection. So we find the frequency terms. We see that we have an attempt, blood spots, cumulatives, and all these words. For the negative, the same will be done for the positive and the review as well. And here is a word cloud representation of the text of the word rather for the negative, and then for the positive review, here is word cloud for it. It deserves significance involved. So we will do the same thing for the review. Thank you. Thank you for watching.